Question number 10 deals with the coefficient of restitution. Yes, coefficient of restitution. It is defined as ratio of relative velocity of separation to relative velocity of approach. Coefficient of restitution E is relative velocity of separation to relative velocity of approach. That is, this is the photograph before collision. Particle of mass m1 moving with speed u1. Another of mass m2 moving speed u2. This is photograph before collision. There are two objects moving in same direction. Say this is moving with u2 and this m1 is moving with u1. One will hit 2 if u1 is greater than u2 for the given scenario. This is before collision. This is before collision. After collision, this is v1 and this is v2. This is after collision. Then E is defined as, yes, from this part, v2 minus v1 velocity of a relative velocity of a separation divided by velocity of approach. This particle was approaching the other particle with what? Difference of the two, u1 minus u2. Suppose this is moving with 4, this is moving with 10. So velocity of approach is 10 minus 4 is equal to 6. So it is u1 minus u2. Special cases. Case 1. E equal to 0. Perfectly inelastic collision. How? If one object is moving with some speed, another object is also moving with some speed, u1 is there, u2 is there, and two objects combined together, they become one object. They become one object. And they have same velocity. v1 is equal to v2 is equal to v final. They have same velocity. Then, if v1 and v2 is equal, E is equal to what? v2 is v final minus v1 is also v final divided by u1 minus u2 is equal to 0. So E is equal to what? 0. If there are two objects moving and after the collision two objects become one object. Like if you drop an object and it sticks to the floor, it doesn't bounce, it sticks to the floor, then the two objects, earth and this material, become one material, is an example of perfectly inelastic collision. This is case number 1. Case number 2, E is equal to 1, perfectly elastic collision. This is a photograph before. u1 is 10, u2 is 5. If two masses are equal, as we will take up in the other question, the two particles exchange their velocities. So, particle number 1 will move with what speed? 5. Other will move with what speed? 10. So, v1 is 5 and v2 is equal to 10. This is after. Particle number 1 was moving with what velocity? 10. 2 was moving with what velocity? 5. After collision, particle number 1 takes speed of the other, velocity of the other, that is 5. And particle number 2 will take velocity of the first one, that is 10. What is value of E for this? Yes, E is equal to V2 minus V1 over U1 minus U2. V2 is equal to what? 10. V1 is equal to what? 5. U1 is equal to what? 10. U2 is equal to what? 5 is equal to 1. So, this is another extreme. Perfectly elastic collision. E is equal to what? 1. Practical cases. Case number 3. Yes. Case number 3. E lies between 0 to 1. Example. Say E is equal to 0.7. If you drop a ball, practical case, yes. If you drop a cricket ball, it will hit the floor, it will bounce back, yes, but not to the same height. This height is h, new height is h dash is less than h. So, E in this case comes out to be what? Neither it is a perfectly elastic collision, nor it is a perfectly elastic, neither perfectly elastic nor perfectly inelastic. It is a case in between the two. That is why E is equal to in between the two, that is neither 0 nor 1. These are extreme cases. E is equal to what? 0.7. 0.7. Most of the cases you have E is equal to 0.1, 0.2, 0.3, 0.4. E is equal to 0 for what? Yes, perfectly inelastic. E is equal to 1 for what? Perfectly elastic. Rest of the collisions are in between the two. Time with you is 3 minutes to write.